Okay. Good morning, everyone.
Good morning.
I know today's a little bit of a blue day, so I'm going to light up the mood.
Oh, Miss Parkes.
And change your attitude towards science. So today, I have a fun little experiment for us. So before we start, I'm just going to go around, and I'm going to pass these objects around. So first, we have this. Arlie, can you tell me what this is?
Tea light.
It's a tea light candle. Go ahead and feel it, don't break the wick off, just take a feel. And then Jasmine, I'm going to start you off with this.
Ooh.
Now it is just
Is
a
this
normal,
Gatorade?
Good question though. It is a normal glass of water, but I dyed it blue so that when I do the experiment, you can see what's going to happen.
Ooh, cool.
But
I can't drink it?
No, you can't drink it.
Oh, okay.
We also have a regular plate. You can feel it. If you want, you can look at the differences between the states that all the objects are in. Here we have a liquid. Mm-hmm. Here we have a solid, or maybe a sockwood, because sometimes these get all liquidy. So if you want to call it a sockwood, we can call them a sockwood. So for today's lesson, we're going to be talking a little bit about air and pressure. So when you blow up a balloon, all those little particles in the balloon are moving around really quick, and that's how the balloon gets really big? Do you remember how we talked about that? So Today, we're going to be doing something a little bit different. So I'm going to take the water, and I'm going to pour it around the candle. Okay? So now let's watch and see what happens. Okay? Wait. Before we do that... Matt, you're interrupting.
Doesn't count as your 15 minutes.
No, it doesn't. Anyways, so before we actually get into the experiment, I want us to think about what might happen if I light the candle and put the glass on top.
What? I wonder.
So we can already see, by looking at the glass, that there's little to no water inside the glass.
Yeah. It pushed out.
How did that?
Weird,
That's
right?
Weird.
Yeah.
So, what do you think could happen if I light the candle?
It blows up.
Do you rate it?
We can
If you light it and put the cup right on top right after.
So I'll light the candle, and then I'll put the cup right on top. So let's go ahead and write down some drawings or predictions or anything that you think might happen. Oh, Jasmine, I love it.
Thanks.
Very nice drawing, girls. Or boys, however you identify. All right, so let's hear some ideas of what you think is going to happen when I light this candle and put the glass on top. Who wants to share? Arlie?
I think that the water will go up the sides of the glass and make it fill all that space that was empty before and go up the sides.
Oh, interesting. So what makes you think that that's going to happen?
Maybe because there's fire and then it makes there be more pressure, so then it sucks up the water.
I like that. Who else has some ideas? Maddie?
I just thought that the candle was going to blow out because there's no fresh oxygen going to it. I didn't think about the water.
Interesting. So far we have a prediction about what's going to happen to the water and a prediction of what's going to happen to the candle. Now, Jasmine,
Blows up.
what is your...
I have a feeling that when you light it, because it's fire and fire is dangerous and if fire blows up, it might just blow up the whole glass.
Interesting. Now, I love all of these ideas. And honestly, there might be a little bit of everyone's that comes into play. Should we find out?
Yeah.
Okay, you ready?
Yeah.
Got my lighter.
Okay.
Adults only.
Okay.
1, 2, wait.
Oh, no.
Aww.
I think we should take a quick vote. So everyone close your eyes. Okay? No peeking. If you feel the need to peek, you can go outside. We're going to take a quick vote just by putting your hand up. So I'm going to read out our 3 options, and I want you to keep your eyes closed and put your hand up for which one you think is going to happen. You ready?
Okay.
So put your hand up if you think that the water is going to go up the sides of the glass. Okay, hands down, eyes still closed. Put your hand up if you think it's going to explode. Okay, very good. Now put your hand up if you think that the candle's going to blow out. Okay, everyone can open their eyes. So we had one person for each vote.
Wow.
Crazy.
It's a tie.
It's a 3-way tie. So should we get into it now and finally see what's going to
Let's do
happen?
it. Let's
Yeah.
Yeah, are we ready?
Yeah.
Mhm.
All right, let's start by lighting our candle.
Oh, she lit it this time.
I lit it this time.
Okay.
Okay? Now I'm going to put the glass on top. But before I put it on top, let's just think back to all the different options that we came up with.
Yeah.
So Arlie thought that the water was going to go up the sides because of the pressure in the glass.
Yeah.
Maddie thought the candle was going to go out because of the lack of oxygen. And Jasmine thought it was going to blow up because everything's just coming into play and there's water, there's oxygen, there's carbon dioxide, there's all these different elements that normally create combustion. What do you think if I told you that it was going to do both?
Cool.
Whoa.
No.
So it's using up all the oxygen that's in there.
And it's just sucking it out.
Oh.
That's,
Oh.
Stop.
my mind is
That's
blown.
actually cool.
That's really cool.
My mind is blown up.
So
Oh my
what
God.
happens?
We were all right.
Yes, you were. That's exactly it. You were all right.
Wow.
So what
Wow,
happens
so cool.
is the flame from the candle is releasing CO2. I'm going to get blue dye all over my face. It's releasing carbon dioxide. So when we enclose the candle in an airtight space, it doesn't have enough oxygen to keep the flame burning. And it's drawing out all of the oxygen and producing more CO2. So the water having oxygen in it, because it's H2O, that's the chemical formula of water, it's replacing the space of where the oxygen used to be. So the candle is fighting for air, and the cup is working like the balloon that we talked about. Because there's so much pressure in there and everything's building up and everything's expanding, it's trying to draw in more energy and more liquid, we can say, in order to get the space filled.
Cool.
Very cool. Very
So that's why when we light the candle and put the glass on top, you may have also noticed the air bubbles coming around.
Yeah.
That was when it was trying to release the CO2, but because the water was in the way, it just ended up sucking
Oh, I
it up
thought it was
instead.
sucking in oxygen. That's interesting.
Well, that's what it was trying to do, right? That's why it was bubbling. It was pushing out the CO2, trying to get the oxygen, but because the water was in the way, it was sucking up the water.
That
Very
is
cool.
neat.
That was very cool.
I
Thank
like
you.
that.
So we had our predictions, we had our explanations, we observed what happened, so now we explained how it happened.
So
There was CO2 in the glass from the flame. And the CO2 was creating more space in the glass. And so it wanted to fill that space, but the only way it could was by sucking up the water.
cool.
That was very cool.
Thank you. Anyone have any questions about it? Want me to do it again? I can do it again.
I do want you to do it again.
That's actually very neat.
So it starts off just sucking it up,
And then,
and then
once,
it's like, oh no, but it's dimming.
yes.
Yeah.
Yeah, it's going out.
And then once it's
That's the
out,
coolest
once
part.
it's out,
There's also different ways to try this experiment. So this is the part where you can add in, like, to further their knowledge. You can add a taller candle or a different shaped glass, and you can test
Yeah,
to see
cool.
if the size of the candle or the size of the glass affects how much water it takes in.
I like it.
totally cool.
Nice.
I like that.
Thank you.
I don't know. I haven't seen the ketchup one, but it seems better.
Ketchup one was pretty cool.
Yeah, I guess.
Wait, what's the
Good
ketchup
stuff.
one?